Welcome back. Hey, we're in section 5.4. I am going to break this guy up into two videos as well. One is going to be dealing with how to factor out the GCF, and the second is about how to factor by grouping. That means, folks, we're in chapter 5, and we're in the end run here now. We are going to take 3 sections and learn how to factor and finally apply factoring, and then we're done. That's the material that we need to digest and be able to perform and practice on the test. Okay, so let's get to factoring. I don't think there's too many strangers to it. First, like I said, the greatest common factors. So I'm giving you notes here, and I'm looking at an example. So let's see what Weber typed in. Let's look at the numbers first. So we're talking about, say, the number 6. And I'm saying you can factor it as 2 times 3. Yay! I know how to factor. In fact, sometimes they have you prime factor and all that jive. All right, great. Now, do a polynomial, because that's our world right now. Let's do this polynomial. And you can see I'm factoring everything. Isn't it weird to factor the x? All right, so I'm doing it this way. 6x minus 4. Well, minus 4 is minus 2 times 2, no problem. But did you know that 6 can be written as 2 times 3? Of course you did. But you see that x? It's also times x. And so what I'm emphasizing in bold-faced here as I go through the problem is there is what they call a common factor. 2 is common to both terms. So there's a 2 in 6x, there's a 2 in 4. That's what's going on in this example. So we write it this way, okay, and it says on this line number 2, now at this stage we can do more, and using the distributive property backwards, remember the distributive property says take a number and multiply through. Well, I'm writing 6x minus 4 is 2 times 3 times x minus 2 times 2. And this 2 that I'm boxing again is common to both terms, okay? And so it's as if someone took the 2 and distributed it. And so so what happens is the 2 gets factored out. The reverse distributive, you factor it out. Or if you distribute it, you multiply it back again, okay? So let me erase this. Let's write it out down here. So 2 times 3x minus 2 is 6x minus 4. This is the binomial. This is the binomial in factored form with the 2 pulled out, okay? And that's the game in our first lecture here right now. We're going to be looking for common factors, and we're going to pull them all out. And at the end, somewhere, I have some rules ideas that'll help you do the homework. Okay, so let's do a couple of examples. Look at the notes, and I'll give you one more, and that'll be this particular video. Okay? All right, so I'm going to take this first polynomial, which is 12x cubed, etc., and I'm going to show you how I kind of do it. But you know what I'm going to do first is what I do in beginning algebra is I take 12 and I prime factor it, which becomes 2 times 2 times 3. That's 12 times x times x times x. Remember, when in doubt, write it out. You don't want to do it this way, but I'm trying to show you something. Minus 8 is 2 times 2 times 2, verify, times x, that's x squared. Minus 10, that's 2 times 5, correct? And then times x. Okay, that's what's going on if you want to really look at it under the microscope. Then you go term by term by term, and you box or circle, the common factors. Everybody has a 2. Terrific. Do they have another 2? Yeah, he does. He does. He doesn't, so stop. Okay? How about 3s? Well, he's the only one with a 3. He's got some extra 2s. And this guy over here has a 5. Okay. So really the only common factor we have is 2. Wait, what about the x's? Let's see. Yeah, everyone has an x, but this guy on the end only has one x. So the only thing that's common to all 3 terms is a 2 and an x. If I write that a different way, you might appreciate that. So it's really equal to 2x, first term, times this stuff right there, which is 6x squared. okay, then minus 2x times, and now who's left over here? Oh, there it is, right there, 4x. And then minus 2x times, and who's left behind this time? Nothing but the 5. Okay? So what I'm doing is I'm showing in red the common factor. In fact, the greatest common factor. I'll put a little note here. The GCF in this case is 2x. Okay? So what do you do with it? That's the thing that separates the men from the boys, or whatever, however you want to say it, is either I'm going to get this or not. I'm going to figure out the GCF and the mechanics behind it, or I'm not. So I'm looking for something, everything that's in common to all three terms. And then the next step is reverse your distributive property. I'm looking here. I'm going to take out a 2x from there, and from there. And in the parens, I'll write what's left behind, which is 6x squared. Looks like it's minus 4x, and then minus 5. This is done. Tedious, I know, but that's how that's done. There's a faster way. I mean, you can look at that and pause, but I'm going to scroll down here and show you. The faster way of doing it is find the GCF, and I'm writing you some notes here. It goes, for the coefficients or the numbers, find the biggest number that divides all the coefficients. So if you go back up here, look at the coefficients of 12, 8, and 10. The biggest number that divides, they're all even, 2 goes in. But you can't go any bigger than that. As you can see by the prime factorization, only 2 goes into all of them. That's the first part. For the variable powers, you select the smallest power you see. So we had x cubed, x squared, and then a single x. Well, you have to go with the smallest x. Why? Because that's all he has. As soon as you take that x away, there's no more he can give. Okay? So we're done with that. And then I have a little word of warning. If a term does not have an x, then your GCF does not have an x either. Okay? As long as it's whatever you can get from all of the terms in the problem. Then the rest is factored out by reversing. Oh, I have a note here that I forgot about. We might try it on the next example. Okay. So here's the next example. Let's actually go. This is the way students would normally do it. If I have to, I'll actually be able to write the answer down here. I'm going to look at the numbers first, and you help me figure this out. Those numbers are kind of hard. I have to figure out the biggest number that divides all of these guys. Sometimes what I do is, what do I do? I take the smallest and see if it divides the others. 16 doesn't go into 24. You have to be pretty good with numbers. Sometimes you could be working on it, your neighbor's working on it, and your neighbor's going faster because they have a better sense of numbers. And that takes me back to elementary school. I'm actually not too good with this, but I have enough experience to look at this and see maybe, oh, maybe 8 goes in here, and 8 goes into 24, and 8 goes, let's try 8. Sometimes if you don't hit the right GCF, you're still okay. Okay, so I'm going to pull out an 8. All right, now we're going to look at the A's. A squared, A. Smallest power, A. And finally, we look at the B's. B squared, B4, B3. Guess what? B squared. All right, that's your GCF. Now you have to divide it out. Okay, let me erase this up here up top. This can actually help. If you think you've got it right, then a good way to go about this is imagine yourself dividing out whatever it is you're factoring out, because that's what you're doing. You're unmultiplying. The distributive property says multiply. When we factor, we unmultiply it back out again. So we are unmultiplying the 8ab squared from each guy. Now this is a visual. If you can do it in your head, great. I can do it in my head. All I do is I go 8 goes into 24 3 times. And then I lose an a. You see the cancellation of the a in the first term? But you still have an a, and the b squared completely disappears. Okay, for the next term, in your head, 8 goes into 16 2 times. What about the a's? They completely cancel. What about the b's? You have a b squared. And finally, 8 goes into 72 9 times. A cancels again, and you're left with a single b. I think we've done it. See how fast that can get? That was a hard problem, but we got that one done. Okay, pause it and stare at that. The last one, and there's the information. This is kind of interesting. I've never done that before, where I wrote, the final answer is GCF, parentheses, each term after dividing out the GCF. All of it added together. Okay, so try this one, and then we'll stop the video. All right, I'll explain to you how it's done, so try it. Okay, assuming you've tried it, then what we do is we write, okay, let's look at the numbers. 15, let's write it. 15, 27, I don't care about negative, 9, and 12. Oh, does 9 go into 12? No. Then something smaller than 9. What about 3? Well, 3 definitely goes into all of them. Is there more? No. Let's just try 3. Okay, look at the variable. Oh, that one's easy. Just x, right? So imagine dividing these guys by 3x. By the way, if you don't, the harder one is the number, isn't it? Figuring out the number that's biggest that divides it is the hardest part. Taking out the lowest power, easy peasy. Dividing, by the way, if it doesn't work, you'll see why when you divide. There might be another number you can factor out. Looks like it's 5x cubed. Looks like it's minus 9x squared. And then plus 3x. And how about a minus 4? That looks pretty good. Look at the numbers, 5, 9, 3. Yeah, those guys don't have anything in common. We're done. Okay, I hope that one helps with the GCF. You got to practice this stuff. So I will, as usual, end the recording.